Hey guys, I hope you had a great fall break, and are glad to be back at co-op this week. Um, this week you have two subchapter worksheets and three lessons. So what we're going to do is I'm going to talk you through the lessons, and then I made copies of the first subchapter for you so that you can get started on it and maybe even finish today so that you are ahead for next week. So, the three lessons that we're going to go over are things that are just not super important. So I'm going to show you how to do them. I'm going to talk about how to do them on the calculator. You can go and watch Edward Berger, how to do them. Whoa, sorry to make you sick. How to do it like, more information if that's what you want, but it's not super important. So that you do it by hand without a calculator. So I'm going to make sure you can do it with a calculator, and that's going to be the key, and then we'll just all move on with our lives. Okay, so I have to make my face go away. Okay, hold on. Don't get sick. There we go. Okay. So first we're going to look at 4.2.1. Okay, and this is about determinants. Determinant. And then something called Cramer's rule. And I'm going to tell you that I'm not a big fan of Cramer and his rule because we can do it with a calculator. So we're not going to talk about that very much. Okay, so first of all, determinant is has to be done with a square matrices. So it can only be done with like a 2x2 or a 3x3. Okay, and it helps us later on when we're trying to find inverse a little bit, although we can do this all with a calculator. But I'm going to show you how to find a determinant with a 2x2, and then I'm going to show you how to find a determinant on the calculator. So this is number 1, and we have 7, 9, 5, 2. Okay, so this is a 2x2 matrix, and we're going to find the determinant. So when you think of a determinant, I'm going to give you a little pattern to follow. A, B, C, D. So the determinant is symboled. So if this is matrix A, right? So to define the determinant, you put straight lines next to it, kind of like absolute value. And you are going to do A, that's not a good A, D minus B, C. So you're multiplying these and then subtracting them from those. Kind of makes a little X. Okay, so A, D is 7 times 2, which is 14, minus C, BC, which is 45. So the determinant of this one is negative 31. Okay, so this, you need to know this little pattern right here, and that's kind of it. So let's look at our calculator. So let's put that same matrix in our calculator. So second matrix, I'm gonna edit matrix A. It's a 2x2, and it is 7, 5, 9, 2. Okay, so there I put it in. So then we hit second quit, and then we go to second matrix again, and this time we're going to go to math. Okay, look at number 1. What do you think DET stands for? You got it. It stands for determinant. So find the determinant of matrix A. Heck yeah, negative 31. Okay, so it can find the determinant for us. That's all we want. Okay, so use your calculator to find the determinant. To find the determinant for a 3x3, I'm going to write it down for you, but use your calculator because it's crazy pants. Okay, so if we have a 3x3 matrix, so we have A, B, C, D, E, F, G, H, I. Okay, so if we have a 3x3 matrix, to define the determinant, you're going to do A times EI minus FH minus B times bi minus fg, yeah, I'm serious, plus c times dh minus eg. Okay, that's to define the determinant. So use your calculator. Okay, enter into matrix A and then use your calculator. Okay, you can do this if you want. I would use my calculator, but that's me. So, the other part of this has you using Cramer's rule to solve a matrices. Guys, we already know how to solve a matrix solving a system. So I don't really want you to waste time on Cramer's rule. So if I gave you, this is number 6. If I give you 4x plus y plus 6 equals 0 and 8x plus 2y equals 9, okay, and I said solve this using a matrix, first you need to move this 6 over, so 4x plus y equals negative 6, 8x plus 2y equals 9. Okay, and if you remember from a few weeks ago, matrix A is 4, 1, 8, 2. Matrix B is negative 6 and 9. You enter those in your calculator, and then you do A inverse B. Okay? So, hopefully you remember that. If not, pause the video, and someone who does remember, review with the class. Okay? So, put this in matrix A, this in matrix B, and A inverse B. Okay? So that is how you are going to solve those. You don't really need Cramer's rule. Next. Okay. Next is 4.2.2. Okay, and this is solving systems using inverse, okay? And I'm going to tell you how to find inverse, but once again, use your calculator, okay? So, first of all, if two things are inverses of each other, when you multiply them together, they get 1. So just like 2 times 1 over 2, those are inverses. If I multiply that together, I get 2 over 2, which is 1. So if I want to know, hey, are these inverses of one another? If I multiply them together, I should get 1. If I don't get 1, not inverse. If I do get 1, it is an inverse. The other thing you can do is just type this in matrix A in your calculator and see what the inverse is. So let's do that. So we're going to type this one in matrix A. So I'm going to go back to second matrix, edit, matrix A. It's still a 2 by 2. It is 8, 4, 2, 1. Okay, then I'm going to do second quit. Okay, then I'm going to do second matrix A. Why do I keep doing that? Second matrix A. Sorry, guys. Quit. Okay, second matrix A. Finally. Then I'm going to hit my little inverse button and hit enter. Oh, no inverse matrix exists, so that cannot have an inverse. Okay, so that's one way to find out what its inverse is to do that. Okay, to see if they match. How to find an actual inverse of a matrix. So this is number 5 on this assignment, and first you're going to do 1 over the determinant, and then you're going to switch. Okay, let me just write this down. So 1, 2, 7, 6. Okay, we are going to find the inverse. Okay, so the first thing you do is do 1 over the determinant. Okay, so remember the determinant on this case would be 1 times 6 minus 2 times 7. So 6 minus 14 is negative 8. Okay, so that's the first thing. 1 over the determinant. Then you take the matrix, you swap these two numbers, 6 and 1, and you make the other two negative. Okay, so you swap A and B, or A, B, C, D. So if I had A, B, C, D, you swap, I'm not sure that's the math word, swap A and D, so D goes here and A goes here, and then make C and B opposite. So right now they're positive, so now they'd be negative. Okay? And then you multiply. So in this case, I'm multiplying times 1/8. So 6 times negative 1/8 is negative 3/4. Negative 7 times negative 1/8 is positive 7/8. Negative 2 times negative 1/8 is positive 1/4. And negative 1/8 times 1 is 1/8. Okay, so this is the inverse of this. Okay, once again, we can do this in our calculator. So I'm going to go back here. I'm going to go back to second matrix. Oh, first I'm going to do that. Second matrix, and I'm going to edit. It's a 2 by 2. It's 1, enter. 7, enter. 2, enter. 6, enter. Okay, so there we go. There's my matrix. Then I'm going to second quit. And then, guys, I can go straight up here because I just found the inverse and hit enter, enter. Okay, there's my answer. That's the same thing we just got. Now, if I want to change that to fractions, math, enter, enter. Okay, now it's fractions. So the calculator can find the determinant for you. Everybody say that again. The calculator can find the determinant for you. The calculator can find the inverse for you. You don't need to know how to do it without a calculator. So let the calculator do the work. Okay, the last section for this next week is something else that we're going to let the calculator do. So it is something called augmentation and row reduction. Okay, some people call it Gaussian elimination or row echelon form. You can look that up in Wikipedia. I hope I sound smart with my big vocabulary, but guys, this can all be done in our calculator the way we have been solving equations before. This has a lot to do with ones and zeros, and it's very frustrating and annoying and hard. You're welcome to go watch it. Watch Edward Berger do it. But I'm going to remind you how you can do it in your calculator. So all it is solving a system. So this is number 2. And it's x plus y plus z equals 10. 2x plus z equals 12. And z minus y equals 3. Okay, so first I'm going to switch this one and do negative y plus z equals 3, just so that it's in the right form. Matrix A is going to be 1, 1, 1, 2, 0, 1, 0, negative 1, 1. Matrix B is going to be 10, 12, 3. In your calculator, you're going to enter these and do A inverse B. Okay, we should practice that. We've done that. It's so much easier than augmented matrix and row reduction. Okay, so row reduction and augmented matrix you're going to end up with zeros and ones, and this number over here is the answer, and this right here is a lot easier. Okay, so make sure you can do that in your calculator. Right now, everyone do this in your calculator. See if you can get the answer. If not, pause the video and make sure everybody can do it. Okay, so you should be able to enter a matrix, like tell a matrix what A is. You should be able to find the determinant. You should be able to multiply two matrices. You should be able to find the inverse, and you should be able to solve a system, all on your calculator. Okay, on calculator. Hopefully you can do all of those things right now, and that would make your life a lot easier. So once again, you've got this these 3 lessons next week, and then 2 subchapter worksheets. So the first subchapter worksheet is over the lessons from last week. So that's what Ms. Clark and Mr. Shorts are going to pass out now. And you should have a good 30 minutes, 25 minutes, 20 minutes, something like that left, and you should get most of that done. Okay, so make sure you can do these things on the calculator. If y'all need to partner up and help each other out, and if not, then just get straight on to the subchapter worksheet, and I will see you guys next week. I will be back in class next week. Like, here's my eye because I will see you. I will see you next week. Okay, bye guys. Have a great week.